We'll see more examples how to find out candidate key by using attribute closure method. Find out candidate key using attribute closure method. For example, the relation contains 4 attributes. Here the given set of functional dependencies are A to B, B to C, C to D and D to E. For this relation, we need to find out all possible candidate keys. Since first we are following this attribute closure method, then first we are finding A plus. By using A plus, we can able to determine A always by using a trivial functional dependency or reflexive rule. Then A determines D, B determines C, C determines D, and D also determines A. A is already presented in the closure set. Then here the closure of A can able to determine all the elements. Here this is also a candidate key. Then next, the candidate key is, the first one is A. Then so coming to the next closure, that is B plus. Then B determines D and B determines C, C determines D and D also determines A. Here this is also a candidate key. Why? Because it is also can able to determine all the elements of given relation. Then coming to the C closure, C determines C, C also determines D, and D determines A, then A determines B. Here C also a candidate key, right? Because it can able to determine all the elements for a given relation. Then next one is D closure. D determines D, D determines A determines B, B determines C. Here this is also a candidate key which can able to determine all the elements. Here what are the possible candidate keys for this relation? A, B, C, D. Here we can also find out by using combination of AB plus. Here AB determines AB and D determines C, C determines D. But this is not a candidate key. Why? Because the subset of AB is A is already a candidate key. The proper subset of A here, A is a subset of L. That's why AB plus is not a candidate key. Like that we can also determine by using AC plus. AC determines AC and C determines D, D determines A determines B. Here AC is also not a super key, not a candidate key. Why? Because the subset of AC is A and C are the candidate keys of the relation. Here, by observing this example, if the key which contains a single attribute, that is always candidate key. But if the key contains more than one element, if no proper subset of that key which cannot able to determine all the elements of a particular relation, then only we can say that is a candidate key. Otherwise, these all are AB plus super keys. AB plus AC plus AB comma AC comma AD, and these all are super key. We can also take that is B comma C, B comma BD, and CD. These all are super keys of a given relation. But what are the possible candidate keys? Here our main goal is to find out all possible candidate keys. In any GATE exams or UGC NET exams, always they will ask for candidate key, which is very, very important. What is a candidate key? The candidate key is a minimal super key which can able to find out all the attributes in a given relation. This is one method for find out all possible candidate keys for a given relation. We will see one more method for finding possible candidate keys for a given relation. The next method to find out candidate key for a given relation is very, very important method. The given relation is A, B, C, D, E, F. The functional dependencies are for this relation, that is A to C, C to B, and B to D, and E to F. We'll write down one by one. The given functional dependencies are A to C, C to B, B to D, E to F. For this given relation, we need to find out all possible candidate keys. Find out all possible candidate keys. In previous method, we are finding candidate key by taking first element and second element, third element. For this method, it is a very simple method. It is very, very important. First, we will observe the given set of functional dependencies. A to C, C to B, B to D, E to F. Then first step is we need to find out the element which is not present at RHS of a given relation. Here by observing the right hand side of the given functional dependencies C, B, D, F. Here the first A is not present. A is not determined by any element, that is any attribute. Then next one is E is not present at the right hand side. Then the second step is, after finding the elements which are not present in the right hand side, then we need to find out closure of that attributes. Then first we are finding this closure of these attributes, the AE plus here AE determines A determines C, and C determines B, and B determines D, and E determines F. Here AE plus can determine all the elements of given relation. Then this is the candidate key for this table is AE. The third step is, if the closure of a attribute can able to find out or determine all the attributes of a given relation, then that attribute set is called candidate key. Then we will see by taking any combinations of these elements. Suppose here if AE is not present at the right side of the functional difference, if without AE we cannot determine all the elements of given relations. If you want to determine all the elements, the AE should be present. Then only we can able to find out all the attributes of a given relations. Here that's why AE is a super candidate key, and it is also called super key for a given relations. Then by taking combinations of AE, suppose if you are taking B, then automatically it will become A. By using BAE, we can able by taking the combination of AE, we can able to determine all the elements. But by using a subset of this attribute set, we can able to determine all the elements of a candidate. By using subset of BAE, we can able to determine all the elements of a given relation. But this is not a candidate key. This is a super key. Why? Because always the candidate key is a minimal super key which cannot be reducible further. The candidate key for this table is AE. This is the one more important method to find out candidate key for a given relation. Okay, these are the steps we need to perform while finding candidate keys for a given relation. Suppose here, if the closure of attribute is cannot able to determine all the elements of a given relation, then we need to take the combinations of other attributes. We'll see one more example to find out candidate keys